Hello, today we're going to be working on finding the volume and surface area of spheres. Now, a sphere is a set of all points that are going to be equidistant from a given point to the center of the sphere. Basically, a ball. Okay, so that's what a sphere is. We're going to find the volume and surface area using different formulas. So the volume formula for a sphere is going to be 4/3 pi r cubed. So 4/3 pi r cubed. The surface area formula for sphere is going to be 4 pi r squared. And there are lots of different proofs to these different formulas, but we're just going to take them as they are. So we're going to go ahead and look at example 1, finding the volume and surface area of the sphere. Now the really nice thing about spheres is that you really only need one thing, and that's the radius. So looking at this, we have that the diameter of a great circle here is 8. So that means the radius of the sphere is going to be 4. So once we find the radius of the sphere, we're just going to plug them both in to once for the volume, once for the volume is going to be 4/3 pi r cubed. And so we are going to simplify all of that. We're going to do 4 cubed, and then we're going to multiply it again by 4, and then put it over 3. So that's 256 over 3 pi. And our units for this one here aren't defined, so that's going to be units cubed. This would be your exact answer. You can type that in on your calculator and get 268.08 units cubed if you'd like. So then for your surface area formula, you're just going to use 4 pi r squared. And so you're going to do 4 squared times 4, and you're going to get 64 units squared. So the surface area, if this helps, is the paintable area. So if this were an orange, it would be the peel of the orange. The volume would be everything inside of it, so it would actually be the edible part. Okay? So we're going to use our formula and work backwards. We have the volume of a sphere given to be 50 units squared. So that's going to end up, oh, that should be cube units. Cubed units. And so we're going to actually plug that into our volume formula. That's going to be the volume, and we're going to use 4/3 pi r cubed to try and figure out what the radius would be. So let's go ahead and get rid of that 4/3 by multiplying by the reciprocal. You get 150 divided by 4 equals pi r cubed. So we're going to go ahead and divide by pi. So we get r cubed equals 150 over 4 pi. And so we're going to go ahead and solve for the radius by getting rid of the cube. Now, if this were a square, you'd look at that and say, hey, I'm going to square root both sides. So the cube is the same thing. We're going to go ahead and cube root both sides. And there's a button on your calculator to do that. And when you do that, you're going to end up getting 2.29 units. If for some reason you did not get 2.29 but you got something else, it might be the 150 over 4 pi part. Let's go ahead and check that real quick. You're actually taking the cubed root of 11.94. See if you got 11.94 when you typed in 150 over 4 pi. If not, that's probably the reason why you didn't get 2.29. So try it one more time or real quick on your calculator. We're going to find the volume and the surface area now for this hemisphere. Find the volume. Normally you would do 4/3 pi r cubed, but we want exactly half of that, so we're going to end up doing 2/3 pi r cubed. And so we're going to do 18 cubed, multiply that by 2, and then divide it by 3. So our total volume for this hemisphere is going to be 3,888 pi meters cubed. To find your surface area, that's going to be a little bit different though, because if we take 4 pi r squared and divide it by 2, we're going to get 2 pi r squared. But the problem is that only gives you the surface area of this top portion, because that would be half the sphere. The problem is that we still have a new surface to account for. We have that kind of base, if you will. We have that circle on the bottom that has now become part of our surface area. So 2 pi r squared gives us everything up top, but that base then is going to be the area of our circle, which is going to be pi r squared which means, interestingly enough, for the surface area of a hemisphere, it's going to end up being 3 pi r squared, which is different than you normally would have thought when you first said, okay, I'm going to take a sphere and cut it in half. What's the surface area? So it's 3 pi r squared, which in this case happens to be 972 meters squared. Okay, so the great circle is the largest circle that can be drawn in any sphere. We've been actually using this already. So we're going to go ahead and move on to example 4 here. We're going to find the volume and the surface area. So we kind of want to divide this up into different chunks. Let's go ahead. We have part A, which is a hemisphere, part B, which is a frustum, and part C, which is another hemisphere. So if we are going to go for the volume, let's do that first. We want the volume of hemisphere A. So we're going to use 2/3 pi r cubed. Okay, so that's for part A. For part B, we're going to have to find the volume of the frustum. So that's going to require a little bit more work. I'm going to pause on part B for a little bit, and I'm going to actually move on to part C. And it's another hemisphere, so it's going to be 2/3 pi r cubed. Okay, so we're going to also now, I'm going to go back to part B. So to find the volume, we first need to know the volume formula for the cone. So the volume formula for the cone is pi r squared h over 3. So we need to do pi r squared h over 3. And what we want to do is we want to take into consideration the larger cone and find that volume, and then we want to subtract away the smaller cone. Okay, so we need the radius of the large cone, the radius of the smaller cone, and the height of both of those. So we can kind of start with what we know. So to find the volume of B, we're going to do pi r squared. So r for the larger one is 8. We don't know the height yet, so we're missing the height of the larger cone, minus pi r squared for the smaller cone, which is pi 6 squared, times the height of the smaller cone over 3. And so now we are going to have to do some work in order to find what that height then is going to be. So I'm going to bump over here, and I'm going to draw out those similar triangles over here. So we said that this was an 8 in the bottom here, a 6 in the bottom here. We are told here that I believe our slant is 16 right here from here to here. So we can go ahead and set up a proportion. So if this is x, we can go ahead and do x plus 16. I'm doing this entire side compared to the corresponding part in the smaller triangle, which is just x, equals the larger one, which is 8, to the corresponding one in the smaller triangle, which is 6. Then we can cross multiply. We can get 6x plus 96 equals 8x. Then we can subtract, and we can get 96 equals 2x, which means that x itself is going to be 48. So this part right here is going to be 48. And now what that allows us to do is it allows us to do the Pythagorean theorem because these are right triangles here. So we do the Pythagorean theorem with 6 squared plus y squared equals 48 squared. And we simplify all of that, and we end up with 18 root 7 in the smaller triangle. And you have a couple of options here. You can do the Pythagorean theorem again, or you can use the fact that these are parallel lines and similar figures. So notice the relationship here between 48 and 16. Since these lines are parallel, it's going to have that same relation from this 18 root 7 to whatever is in the other part of the triangle down here. So if you either do similar triangles or the Pythagorean theorem again, you're going to end up with 6 root 7 for this distance here, which means my entire height of the larger cone then is going to be 24 root 7. Okay, so now I'm going to zoom back out and over here a little bit. So to find the volume, once again, we did the part A, part C, and we're trying to find the volume of part B by doing the volume of the larger cone minus the volume of the smaller cone. We used similar triangles to find the height of the larger cone to be 24 root 7. And then we also found the height of the smaller cone to be 18 root 7. And so now what we can do is we can combine everything and simplify it. The problem is going to be the root 7 parts. So like these two terms here are going to combine nicely with each other because they both have root 7s. But they're not going to combine nicely with the other parts that don't have the root 7. So I'm going to combine the shapes I just highlighted in orange. And when I do that, I'm going to get 1456 over 3 times pi. And then I'm going to combine the parts with the radical 7s, and I'm going to get 888 root 7 over 3 pi, which this would be our exact answer, units cubed for volume. However, it's not very nice, so I'll also write the decimal approximation to see if you got it right that way. 3,985.03 units cubed overall. Okay, so now we have the volume done. We're also going to go ahead and calculate the surface area. So we need a plan for the surface area. So we want to do the hemisphere for part A, but we'll notice if this is painted, only the actual outer part here is going to be the painted part. It's not going to include the base, that bottom part, like we did on the other hemisphere example. So for part A, we're actually going to use 2 pi r squared for the hemisphere. I'm going to jump to part C as well because that's again a nicer one here. We're going to do the hemisphere but not include the base of that circle. So it's just going to be 2 pi r squared. And then we also need the part B. Now for part B, the paintable area is actually the lateral area of the bigger cone minus the lateral area of the smaller cone. And so for that one, the lateral area of the bigger cone is going to be pi r L. And our slant height for that one is going to be the 48 plus the 16, or a total slant height then of 64. And the lateral area of the smaller one is going to be pi r L. And our slant height for that one is just 48. And so now these ones actually are going to combine rather nicely. The 2 pi times 6 squared, that's going to end up being 72 pi. The 2 pi times 8 squared, that's going to be 128 pi. The lateral area of the bigger one is 512 pi, but we're subtracting away the lateral area of the upper cone, which is going to be 288 pi, for an overall of 424 pi units squared. Or if you found it as a decimal, 1,332.04 units squared. So I'm going to stop here for part 1. I'll do examples 5 and 6 in the next video. Thank you for listening.